friends. Today I got a good lesson for you because I think we all need to learn this lesson up here. Today's lesson, lesson 105, is on page 781. Now with lesson 105, one of the things you guys are going to be working on is looking at a problem and choosing which formula to use. Am I finding the area? Am I finding the perimeter? Am I finding the volume? So that's what this whole lesson is about. Just using those formulas in the right way based on what the question is asking you. Which on, I think it's test 20B, the one we took last Friday, that was kind of an issue for us because some of us got mixed up. Like, wait, do I write with square inches or square feet? Or is it regular inches or regular feet? Cool. So let's grab out those math books. Make sure you have your math sheet sitting out last night's and tonight's, so you can, or yesterday's and today's, and I guess it's not nighttime. So we can check lesson 104 when you're done with this, and then we got lesson 105 chilling right here. So once again, page 781. Look at that. There goes the clock again. All right. So, right at the top it says formulas describe processes for solving certain types of problems. Formulas often use letters and other symbols to show the relationship between various measurements. In the examples that follow, we're going to use formulas to solve problems about perimeter, area, and volume. So we got a little room right here. The one in the book looks a lot better than mine because I drew this one and voila. All right, so let's check out example number 1. It says the Jacksons have added a dining room to the corner of their house. Mr. Jackson purchased crown molding that will be installed at the intersection of the walls and the ceiling of his dining room. So crown molding goes up here in the corners. If you look around your house, if you got a super nice house, you probably have it. It's got, like, instead of just seeing where the wall meets like this, there's like a little wooden piece or whatever that's shot up there into the corner, so it's like curved and kind of bumpy. It looks real cool. Yeah, I don't have it in my house. That's fine. So he's going to put that up there though, and it says the crown molding cost $5 per foot. All right, here we go. Excuse me. So we need to figure out how many feet around just the top there is. So would we use perimeter, like the formula for perimeter, area, or the formula for volume to try to figure that out? Let's see, who hasn't answered anything in a while? Can't remember if I called on you, Ryan, or not, but Ryan, help me out. All right, if I'm looking at just around the top, which one of those am I going to use? Perimeter, right? And remember, perimeter is 2 times the length plus 2 times the width. Now, how long is this side of the room? We can see it down here on the bottom. It's 12 feet. I guess that's our width. So we're going to go 2 times 12 plus 2 times the length. How long is the room? It's 15 feet. Okay, so what's 2 times 15, Ryan? Okay, yeah, absolutely, 30. And then what's 2 times 12? Gotcha, 24. Now we add those two up, that's going to give us how much? 54 feet. Now it's just feet, it's not feet squared, it's not feet cubed, it's none of that, it's just feet because it's how long it is. It's not taking up any space. Now we got to come up with how much is it going to cost, because we have 54 feet and it's $5 a foot. So let's multiply 54 times 5. What's 5 times 4, Ryan? Absolutely, there's 20. Carry the 2, 5 times 5 is 25, and then 25 plus 2 is 27. Awesome. So right there, it's going to cost 270 bucks. But truthfully, if you're really going to do this at home, you add I think it's 5 to 8% extra, because every now and then you got to cut a piece to fit into a corner, and then all of a sudden, you don't have enough pieces. So yeah, if you ordered 54 feet, it's probably not going to work. You're going to have to get like 64, something like that. Sweet, let's look at example number 2. Go ahead and turn the page. We've got the same picture going on. Now it says, Mrs. Jackson wants to buy a carpet for the dining room floor. How many square feet? There's a hint. How many square feet of carpet is she going to need for the floor? Now we're talking about area, right? She's talking about all this area down here. Just like that. So, to find the area of that space on the floor, what are we going to multiply? Area equals what? Who thinks they know? Let's see. Melissa, what do you think? Yeah, it's just length times width, right? So, how wide was the room? Yep. How long is the room? We saw it up there in the top. All right, cool. I'm going to write it vertically because it messes with my brain to look at it horizontally a little bit sometimes. Cool, so let's write it this way. So Melissa, help me out. 2 times 5. Carry that 1. 2 times 1 plus 1. Absolutely. We got to put our space holder in there. What's 1 times 5? Absolutely. 1 times 1. We add all those up. 0 plus 0 is 0. 5 plus 3, 8. 1 plus 0, 0. And then we are talking about feet. And since we're talking about area, what's it got to be? Do we leave it feet, or do we got to put a 2 or a 3? What do we put on there? We got to put a 2. So we got 180 square feet worth of carpet that she needs to buy for that room. Okay, now comes to the tricky one, the last one. They also have to add an air conditioner to cover the extra volume. See what I did there? The extra volume of that space. So, who remembers what the equation for volume is? If you look at the example in the book, it will tell you. It is length times the width. But we also got to multiply the height. All right, so if you're paying attention to what we've done so far, this should be pretty easy. Because we just did length times width, right? How much was it? 180 feet. So we can go ahead and steal what we already know there. Now all we have to do is multiply times the height. So let's see. Maddie, help me out, Maddie. If I've already got my length times the width was 180, now all I have to do is multiply it by the height. How tall is it? Absolutely, it's only 10 feet tall. So now 180 times 10, all we got to do is move that 0 up there right next to it, right? Voila. Now the other way to do it, we could set it up like this. So if we go 180, we set that 10 out there by the side, we drop the 0 down, and then you just multiply times 1, right, Maddie? 1 times 0, 1 times 8, 1 times 1. So we have 1,800 feet. What's it going to be? Is it going to be a little 2 or a little 3? Maddie, what do you think? What do you think? Huh? Yeah, it's going to be a 3. 100 or 1,800 feet cubed is going to take up all that space in there. Sweet. All right, all right, all right. Now we are on to example 4, and we're talking about this trunk right here. Let's see, it's got a little picture of some horses going across here. You know, that's going this way. Got the little latch thing here on the top. All right, cool. Let's check out A. Man, Mrs. Jackson, she's all over the place. What's up, y'all? So Mrs. Jackson, for A, it says plans to put a liner on the bottom of the trunk. So if we could see the bottom, let's say, all right, so she wants to put something all across the bottom of this trunk. And let's see, it would come down there somewhere. All right, cool. Now, what formula am I going to use? Say she wants to put a piece of paper down there. What kind of formula am I going to use? Am I going to do our perimeter? Is that the distance around the outside? Am I going to use area, which is the space on the bottom? Or am I going to go with the volume, which would fill the entire thing? Does she want to fill the entire thing with paper? I don't think so. So I think volume's out. We don't want to do volume on this one. Now, does she just want to put the paper around the outside edges? No, that's not what she wants either. So perimeter's out. So that leaves us with area. So we got to go length times the width to find the area in inches. Now we got some big inches here, 36 inches, and we got 30 inches to try to work this out. Now I'm going to go to Nicholas. Nicholas, help me out. So we got to go 36 times 30 inches. So inches. Sweet. Now, Nicholas, like we just did here, we dropped that 0 straight down. Woo! Now all we got to do is multiply by 3, bud. What's 3 times 6? There you go, 18. Carry the 1. 3 times 3 is 9 plus 1. So 1,080 inches. And then, now, is it going to be, look what we did when we did area. We squared it because we only multiplied it. How many times do we see inches? We see it 2 times. So that means we're going to square our answer. Now, let's look at B. So this was A. B is saying Mrs. Jackson also plans to paste a border of horses all the way around the outside. Now, all the way around the outside. What formula did we use for that in example 1? Exactly 2 times length times 2 times height. Plus 2 times height. I think that's, or width. That's what we got right there. 2L plus 2W. Haha. All right, let's try it out. So it's 36 inches long. So we're going to go 2 times 36 plus 2 times 30. All right, 2 times 36. Woo, man. I'm going to go with Grayson J in my class. Grayson, help me out. So 2 times 36, so 2 times 6 is 12. We carry that 1. 2 times 3 is 6 plus 1. All right, so we got 72 inches there, plus 2 times 30. 30 times 2, that's a pretty easy one, right? 2 times 0 is 0. 2 times 3 is? Nice. So we got 60 inches. Sweet, let's add those up. What's 72 plus 60? 132 inches. Now remember, that's just inches long because we're not squaring it. It's not taking up space. It's just going around and around and around and around and around and around and around. All right, good deal. Let's see. All right, I'm going to pause this and I'm going to get rid of all this writing. We're going to keep our pictures for our next part though. All right, here we go with lesson practice. We're on A. Let's do this thing. It says the Jacksons want to cover one 12-foot long wall with a dining room with wallpaper. How many square feet are they going to need? So square feet tells us we're looking at area, right? Area equals length times width. Now, a 12-foot wall. So they want to cover this entire wall with wallpaper. Okay, what are the dimensions of that wall? What is the length and the width? So one side's 10 feet, the other side's 12. So 10 times 12 is going to equal how much? Let's go to Allie. What's 10 times 12? Absolutely, 120. And then what were we talking about? We're talking about feet. And then we're talking about area. So what do I need to put? A little 2 or a little 3? There you go, a little 2. Got to have it squared. They need 120 square feet of wallpaper. Now check out B. B says calculate the storage capacity of DeMont's toy box from example number 2, or whatever that was, example 4. I think it was like example 4. So for B, we got to figure out what is the volume. Remember, we got length times width times height. Now, this is in inches, and that number is going to be ginormous. So let's go ahead and turn this into feet. Okay, so 36 inches is how many feet? Gracie D, help me out. 36 inches, how many feet is that? Yep, that's 3 feet. Now, 24 inches, that's an easy one, right? Well, how many feet is that? Yep, that's 2 feet. And then 30 inches, that's where it gets tricky. But notice it gives you a hint. It says that equals 2 2.5 feet. All right, so let's plug it in. Our length is 3, our width is 2.5, and our height is 2. Now, I'm gonna multiply the whole numbers first and then multiply times the decimal number because it makes it easier that way. What is 3 times 2, Gracie? Absolutely, it's 6. So now we can multiply 6 times 2.5. Now 6 times 5 is how much? Yep, it's 30. We carry that 3. What's 6 times 2? Yep, it's 12. And then 12 plus 3 absolutely is 15. Now we got one decimal place there, so we're going to scoot over one spot. We're going to drop it in right here. So we got 15. I want to simplify, so I'm going to get rid of that 0 right there. So we got 15. We're talking about feet. And then how many times did we multiply? 1, 2, 3. So we had 1, 2, 3 feet. So we got to put what, Gracie? Is it going to be a 2 or a 3? Yep, it's going to be a little 3 because we're talking about volume. Remember, area squared, volume is cubed. Awesome job. Let's check out C. It says the following diagram is a top view of the Jackson's house showing the outside walls. The dashes show the outside walls of the new dining room. Calculate the perimeter all the way around the house. So we have, let's see, this kind of shape. And then it's got the little dots, voila. So this is 3. I guess letter C. We'll make it a C. Let's see, we got 15 feet up here. We got 25 feet right here. And then really this is the only one we need to know, the 35 feet over there. Now if I'm doing perimeter, remember it's 2 times the length times 2 times the width. All we gotta do is multiply those up, add them together. That's gonna give us our perimeter. So let's put that up here. So perimeter equals 2 times the length plus 2 times our width. Now, here's one of our widths, 35. So we got 35 times 2, so that's going to be 75 feet. And then up here, we got to add these two together to get the full distance, correct? So we got 15 plus 25. And let's see, if I go over to Ava, 15 plus 25 is how much? 5 plus 5 is 10, right? We carry the 1, so we got 2 plus 1 is 3, plus that 1 we just carried, so that's 4. So this side right here is 40 feet long, but I got 2 sides that are that long, so that means 40 times 2 is how much, Ava? There you go, it's 80 feet. So we got 80 feet plus 75 feet. What's that going to give us, Ava, for the total distance perimeter around their house? Wait a minute, I did that wrong. 35 times 2 is 30. Or 70. Whoopsie daisies. You caught me, Ava. Good job. All right, so what's 80 plus 70? What's that equal? Absolutely. 150 feet. And we just label it feet. We don't go squared because remember, if we're talking about area on the inside, then we're going to use a little 2. But since we're only talking about the distance on the outside, we're good. We don't have to put that. Awesome. Now it's time. Go grab that math sheet so that we can go over some of your homework for tonight and then have out last night so we can check in when we're done. All right, here we go. So you should have that math sheet out so it can help you out with some of these problems. Let's take a look at number 1. On number 1, all you got to do is add together all the numbers they're giving you and divide by 3. So that's a pretty easy one. Number 4, they give us that 6-sided cube. Now they want us to find the area of the cube, of just the face, the first face of the cube, any face really. So you got to find the area. I already wrote it up there. You got to figure out what it's going to be, right? Because 6 times 6, you can figure that out. And then they want to find the total surface area of the entire shape. Now you're going to take your answer for A and multiply that times 6 for B. All right, good. I hope we're good. Now 6 is a difficult one. I got to grab my book because I forgot the picture. Let's see. We have a shape. Ooh, thing's kind of crazy looking, right? Now, if you look at it from the front's a pretty easy, it's just a regular six-sided shape right there. So you must draw that six-sided shape. Now, it gets a little trickier when you're looking at it from the top. So imagine you see the top, correct? The top's going to look something like this. But then also you're going to see two of the sides. So you're going to see these kind of skinnier looking sides on each side there. Now, when you look at it from the side viewpoint, looking at it directly from the side, you're going to see two equal sized rectangles looking at it from that way. I'll make you figure out what the front would look like. It's pretty easy. Now check out number 7. Number 7 tells us find the percent of each number by changing the percent to a decimal. So here's my percent, 7%. We're going to start here. We're going to move over 2 spaces and drop our decimal in here. We can put a 0, totally fine. Cool. Now we can get rid of that percentage sign, then we just have to multiply. Let's run to, Nicholas already went, Ava went, Gracie went. Reagan, help me out, Reagan. All right, now we're just multiplying times 7. What's 7 times 0? 0. What's 7 times 5? Okay. 35, carry that 3. And then 7 times 1 is 7 plus 3. Absolutely, makes 10. Now, how many decimal places over were we? 2. So let's scoot over 2 spots. Drop our decimal right in there. 10.50, and we are good to go. Oh, we want to simplify, right? So am I going to leave that 0 on there if we simplify our answer? No, let's just get rid of it just like that. Sweet. There is our simplified decimal answer, 10.5. Sweet. Number 9 is crazy. Check out number 9. Remember, when we did the lesson on lowest common multiple, lesson 103, we had huge numbers like this, and they wanted us to use prime factorization to try to find what the lowest common multiple between these two numbers would be. So let's do that. Let's use. I'm going to use factor trees because I like factor trees. Asher, help me out. What 2 numbers can I multiply to get 15? Okay. That's it, right? Besides 1 and 15, but those aren't prime numbers, so we got to go 3 and 5. Now, what 2 numbers can I multiply? There's a couple sets that we can multiply to get 16, right? We can go 2 times 8, or we can go 4 times 4. Let's go 4 times 4. I like that. All right, what 2 numbers do we multiply to get 4? There you go. 2 times 2. And then this 4, we got to do the same thing, right? 2 times 2 again. Cool. Now remember, if we write the prime factorization, we had 4 little 2, so I have 2 to the 4th power. And then we would have had 3 times 5 over here. Now, when we're looking for the lowest common multiple, we got to take everything that we see and multiply those together. Now, remember, if I had a 2 over here, we'd cross that 2 off because this 2 is bigger. So we're going to go with this guy. So we're going to go 2 to the 4th power times 3 times 5 equals, and then, hold on, I've got to erase my 2 to the 4th power real quick. All right. There we go. Equals, all right, but here's something real quick to notice. Notice we used all the numbers here, we used all the numbers there with that 2 to the 4th power, right? So basically, to work this out, we could just multiply 15 times 16. So let's do that. We got 15 times 16. So Asher, help me out. What's 6 times 5? Yep, there's that 30, 3 to the top. 6 times 1, 6 plus 3, 9, I like it. And then we got to put a space holder because we're multiplying times the 1, right? What's 1 times 5, Asher? And then 1 times 1? Awesome, let's add. We got 0, we got 14, and then we carry the 1. There's 2. So this is our complete answer right here. So 2 to the 4th power times 3 times 5 equals 240. And that's the lowest common multiple for that number right there. All right, check out number 12. Number 12, they want us to write it as a mixed number and then also as an improper fraction. So I'm going to go to Yosemite on this one. How would I write this as a mixed number? How many full shapes do we have? We got 4 full ones, and then what fraction do we have of this one? 1, 2, and then how many are in each one? 5. Sweet. So there's our mixed number. Now we got to make it improper. So remember, we multiply our denominator times our whole number. So what's that equal? 4 times 5. Yep, that's 20. And then what's 20 plus 2? Absolutely, 22. And then remember, your denominator stays the same. We got 22 over 5. Sweet. Let's check out number 14. 14 is one of those ones we kind of have problems with on our test. So let's roll over to Micah. Micah, help me out on 14. We got 6 times 4. Yep. And then we carry that 2. 6 times 1 is 6 plus 2, 8. Now, Micah, how many spaces do we have? We got 2 there. We got 1 there. So we start here. We go 1, 2, 3. We got to put a little decimal point right there. And we got to fill that open spot. So we got 0.084 for our final answer. Here, I'm going to chuck that over there. So check out 26. We got the square root of 9 plus the square root of 16. So who could help me out? What is the square root of 9? Joseph, help me out. What's that equal? Yep, that's 3. And then what's the square root of 16? And then we're comparing that, and that totals 7. Now, what's 9 plus 16? All right, cool. So that's 25. So truthfully, we're trying to solve what is the square root of 25. So, Joseph, what's the square root of 25, bro? Absolutely, it is 5. So which one of these is bigger? We want to have our alligator TV and that guy right there. All right, on to number 27. It says 2/12 of the months of the year start with the letter A. I think that's what the question was. Yeah, April and August, sound right? All right, cool. Now, let's reduce this fraction to go ahead and work this out. Now, what number goes into both 2 and 12? Let's run over to Grayson M. Room 10, help me out, bro. Absolutely, 2 goes into both these. What's 2 divided by 2? 1. What's 12 divided by 2? 6. Nice work. Now, we're going to multiply times 100% over 1. So, what is 1 times 100, Grayson? Absolutely. And then what's 6 times 1? I like it. Now, let's figure out what our percentage is. We can even put our little percent sign on there just for fun. All right, 6 goes into 10 how many times, Grayson? Yep, there's that 6. And there's a 4. We drop down our 0. 6 goes into 40 how many times? Nice. 6 times, and there's 36. And we got to do a little borrowing, becomes a 10. There's 4. So we got 16 and 4, 6. So our remainder is 4, 6. Can I make that fraction smaller, Grayson? Absolutely. I could reduce both those by 2, right? So that gives me 2/3. So 16 and 2/3%. Awesome. Make sure you guys get this stuff copied down, and then have out your math sheets from last night so you can check your answers. All right. Later.